Section 11.5, Integrating Spring Security with SPAs. The web front-end part of microservice architectures and other distributed systems is often built as one or more single-page applications using frameworks like Angular, React, or Vue. Analyzing how SPAs are created is not in the scope of this book, but it's essential to look at what changes are needed to support such front-end clients. So far, you have interacted with the services composing the Polar Bookshop system through a terminal window. In this section, we'll add an Angular application that will be the front end of the system. It will be served by an Nginx container and be accessible via the gateway provided by Edge Service. Supporting an SPA will require some additional configuration in Spring Security to address concerns like cross-origin request sharing, CORS, and cross-site request forgery, CSRF. This section shows how to do that. Section 11.5.1, Running an Angular Application. The Polar Bookshop system will have an Angular application as the front end. Since this book doesn't cover front-end technologies and patterns, I have prepared one already. We just need to decide how to include it in the Polar Bookshop system. One option is to let Edge Service serve the SPA static resources. Spring Boot applications serving a front end usually host the source code in src/main/resources. That's a convenient strategy when using template engines like Timeleaf, but for SPAs like Angular, I prefer keeping the code in a separate module. SPAs have their own development, build, and release tools, so having a dedicated folder is cleaner and more maintainable. Then you can configure Spring Boot to process the SPA's static resources at build time and include them in the final release. Another option is to have a dedicated service take care of serving the Angular static resources. That's the strategy we'll use for Polar Bookshop. I have already packaged the Angular application in an Nginx container. Nginx.org, provides HTTP server features, and it's very convenient for serving static resources such as the HTML, CSS, and JavaScript files composing the Angular application. Let's go ahead and run the Polar Bookshop frontend, Polar UI, in Docker. First, go to your Polar deployment repository and open your Docker Compose file, docker/dockercompose.yml. Then add the configuration to run Polar UI and expose it through port 9004.
Listing 11.12, Running the Angular application as a container.
Like the other applications in the Polar Bookshop system, we don't want the Angular application to be accessible directly from the outside. Instead, we want to make it accessible via the gateway provided by Edge Service. We can do that by adding a new route for Spring Cloud Gateway to forward any requests for static resources to the Polar UI application. Go to your Edge Service project, Edge Service. Open the application.yml file and configure the new route as follows.
Listing 11.13, Configuring a new gateway route for the SPA static resources.
The URI for the Polar UI application is computed using the value from an environment variable, SPA_URL. If it's not defined, the default value written after the first colon symbol will be used. Note: when running Edge Service as a container, remember to configure the SPA_URL environment variable. On Docker, you can use the container name and port as the value, resulting in Polar UI 9004. Let's test it out. First, run the Polar UI container together with Redis and Keycloak. Open a terminal window. Navigate to the folder where you keep your Docker Compose file, polardeployment/docker/dockercompose.yml, and run the following command.
See this code?
Then build the Edge Service project again and run the application ./gradle-w-bootrun. Finally, open an incognito browser window and navigate to localhost 9000. Spring Security is configured to protect all endpoints and resources, so you'll automatically be redirected to the Keycloak login page. After you authenticate as either Isabel or Bjorn, you'll be redirected back to the Edge Service root endpoint from which the Angular frontend is served. For now, there's not much you can do. The authentication flow is triggered by Spring Security when it receives an unauthenticated request, but it won't work if it's an AJAX request due to CORS issues. Furthermore, POST requests, including the logout operation, will fail due to the CSRF protection enabled by Spring Security. In the following sections, I'll show you how to update the Spring Security configuration to overcome those issues. Before moving on, stop the application with Control-C, but keep the containers running, you'll need them. Section 11.5.2, Controlling the Authentication Flow. In the previous section, you tried accessing the Edge Service homepage and experienced being automatically redirected to Keycloak to provide a username and password. When the front end consists of server-rendered pages, such as when using Timeleaf, that behavior works fine, and it's convenient since it doesn't require any extra configuration. If you're not authenticated yet, or your session has expired, Spring Security will automatically trigger the authentication flow and redirect your browser to Keycloak. With a single-page application, things work a bit differently. The Angular application is returned by the backend when accessing the root endpoint through a standard HTTP GET request performed by the browser. After that first step, the SPA interacts with the backend through AJAX requests. When the SPA sends an unauthenticated AJAX request to a protected endpoint, you don't want Spring Security to reply with an HTTP 302 response redirecting to Keycloak. Instead, you want it to return a response with an error status like HTTP 401 unauthorized. The main reason for not using redirects with SPAs is that you would run into cross-origin request sharing, CORS, issues. Consider the scenario where an SPA is served from client.polarbookshop.com and makes HTTP calls through AJAX to a backend at server.polarbookshop.com. The communication is blocked because the two URLs don't have the same origin, the same protocol, domain, and port. That's the standard same origin policy enforced by all web browsers. CORS is a mechanism for allowing a server to accept HTTP calls through AJAX from a browser-based client like an SPA, even if the two have different origins. In Polar Bookshop, we serve the Angular front end via the gateway implemented in Edge Service, same origin. Therefore, there aren't any CORS issues between these two components. However, suppose Spring Security is configured to reply to an unauthenticated AJAX call with a redirect to Keycloak, having a different origin. In that case, the request will be blocked because redirects to different origins are not permitted during AJAX requests. Note: to learn more about CORS and Spring Security, you can check out Chapter 10 of Spring Security in Action by Laurentiu Spilka, Manning, 2020, where the subject is explained in great detail. For a comprehensive explanation of CORS, see CORS in Action by Mansour Hossain, Manning, 2014. When changing the Spring Security configuration to reply with an HTTP 401 response to unauthenticated requests, it's up to the SPA to handle the error and call the backend to initiate the authentication flow. Redirects are only a problem during AJAX requests. The crucial part here is that the call to the backend to start the user authentication is not an AJAX request sent by Angular. Instead, it's a standard HTTP call sent from the browser, like the following.
See this code.
I'd like to stress that the login call is not an AJAX request sent from the Angular HTTP client. Instead, it instructs the browser to call the login URL. Spring Security exposes in /OAuth2/authorization/registration ID endpoint that you can use to start the authentication flow based on OAuth2/OIDC. Since the client registration identifier for Edge Service is Keycloak, the login endpoint will be /auth2/authorization/Keycloak. To make that possible, we need to define a custom authentication entry point to instruct Spring Security to reply with an HTTP 401 status when an unauthenticated request is received for a protected resource. The framework already provides an HTTP status server entry point implementation that perfectly suits this scenario, since it lets you specify which HTTP status to return when a user is required to authenticate.
Listing 11.14. Returning 401 when the user is not authenticated.
At this point, the Angular application can explicitly intercept HTTP 401 responses and trigger the authentication flow. However, since the SPA is now in charge of starting the flow, we need to permit unauthenticated access to its static resources. We would also like to retrieve the books in the catalog without being authenticated, so let's permit GET requests to the /book/ endpoints as well. Go ahead and update the security web filter chain bean in the security config class as follows.
Listing 11.15. Allowing unauthenticated GET requests to SPA and books.
Let's test how Edge Service works now. Ensure that the Polar UI, Redis, and Keycloak containers are still running. Next, build and run the Edge Service application, /gradle boot run, and then go to localhost 9000 from an incognito browser window. The first thing to notice is that you don't get redirected to the login page, but are presented with the Angular front-end application immediately. You can start the authentication flow by clicking the Login button in the upper right menu. After logging in, the upper right menu will contain a Logout button, which is only shown if the current user is successfully authenticated. Click the button to log out. It should trigger the logout flow, but it won't work due to CSRF issues. You'll learn how to fix that in the next section. In the meantime, stop the application with Control-C. Section 11.5.3, Protecting Against Cross-Site Request Forgery. The interaction between the front-end and back-end is based on a session cookie. After the user is successfully authenticated with the OIDC/OAuth2 strategy, Spring will generate a session identifier to match the authenticated context and send it to the browser as a cookie. Any subsequent request to the backend will have to contain the session cookie, from which Spring Security can retrieve the tokens associated with the specific user and validate the request. However, session cookies are not enough to validate requests, which are vulnerable to cross-site request forgery, CSRF, attacks. CSRF affects modifying HTTP requests like POST, PUT, and DELETE. An attacker could induce users to perform requests they didn't intend by forging a request meant to cause harm. Forged requests could do things like transfer money from your bank account or compromise critical data. Warning: many online tutorials and guides show how to disable the CSRF protection as the first thing when configuring Spring Security. That's dangerous to do without explaining the reasoning or considering the consequences. I recommend keeping the protection enabled unless there's a good reason not to. You'll see one good reason in Chapter 12. As a general guideline, browser-facing applications like Edge Service should be protected against CSRF attacks. Fortunately, Spring Security has built-in protection against such attacks. The protection is based on a so-called CSRF token generated by the framework that's provided to the client at the beginning of the session and required to be sent along with any state-changing requests. Note: to learn more about CSRF protection in Spring Security, you can check out Chapter 10 of Spring Security in Action by Laurentiu Spilka, Manning, 2020, where the subject is explained in great detail. In the previous section, you tried to log out, but the request failed. Since the logout operation is available through a POST request to the /logout endpoint, the application expects to receive the CSRF token generated by Spring Security for that user session. By default, the generated CSRF token is sent to the browser as an HTTP header. However, Angular applications cannot work with that and expect to receive the token value as a cookie. Spring Security supports this specific requirement, but it's not enabled by default. You can instruct Spring Security to provide CSRF tokens as cookies through the CSRF DSL exposed by Server HTTP Security and the Cookie Server CSRF Token Repository class. For imperative applications, that would be enough. However, for reactive applications like Edge Service, you need to take an extra step to ensure the CSRF token value is actually provided. In Chapter 8, you learned that reactive streams need to be subscribed to in order to activate them. At the moment, Cookie Server CSRF Token Repository doesn't ensure a subscription to CSRF token, so you must explicitly provide a workaround in a web filter bean. This problem should be solved in future versions of Spring Security. See issue 5766 on GitHub, this link. For now, update the security config class as follows.
Listing 11.16, Configuring CSRF to support a cookie-based strategy for SPAs.
Let's verify that the logout flow works now. Ensure that the Polar UI, Redis, and Keycloak containers are still up and running. Next, build and run the application, /gradle boot run, and then go to localhost 9000 from an incognito browser window. Start the authentication flow by clicking the Login button from the upper right menu. Then click the Logout button. Under the hood, Spring Security will now accept your logout request. Angular adds the CSRF token value from the cookie as an HTTP header, terminate your web session, propagate the request to Keycloak, and finally redirect you to the home page, unauthenticated. Thanks to this change, you can also perform any POST, PUT, and DELETE requests without receiving a CSRF error. Feel free to explore the Angular application. If you start up catalog service and order service, you can try adding new books to the catalog, modifying them, or placing an order. Both Isabel and Bjorn can perform any action at the moment, which is not what we want, since customers, like Bjorn, shouldn't be allowed to manage the book catalog. The next chapter will cover authorization, and you'll see how to protect each endpoint with different access policies. Before addressing authorization, though, we need to write autotests to cover the new functionality. That's coming up in the next section. Before moving on, stop the application with Ctrl-C and all the containers with Docker Compose down, from Polar Deployment/Docker